Okay, so turn around, please. Today is just a continuation of what we were doing last day, figuring out the exact values of trigonometric ratios, except now we're going to be working with double angles. Okay? Double angles are just a new set of formulas that you're going to need to know how to use, not to memorize. The double angle formulas at the bottom of your formula sheet. So I'm just going to show you where the double angle formula for sine comes from, and then you can develop the cosine and tangent on your own for fun if you want to. Okay, so the sine of any angle added to another angle is equal to the sine of that first angle times the cosine of the second angle plus the cosine of the first angle times the second angle. So if I use the addition formula for x plus x and expand that using my addition formula, well, we know that the sine of x plus x is equal to the sine of the first angle times the cosine of the second angle added to the cosine of the first angle times the sine of the second angle. So I have sine x cos x and cos x sine x, the exact same term, just in different order. So that means I have two of them. So the sine of x plus x, which can be written as sine of 2x, because x plus x is equal to 2x, is equal to 2 times the sine of x times the cosine of x. So if ever you want to figure out the sine of 2 times an angle, when you're given the original angle, you can use this double angle formula. Okay, so we'll do a quick example of very similar to what we did last day, where I give you some information about the angle, and then you use that information and draw yourself a diagram so that you can figure out other information about that angle and then answer exact values. So, example, given that the cosine of x is equal to negative 3 over 5, and angle x is between pi over 2 and pi, determine the exact value of, and we'll start off fairly simple. I want to figure out what the value of sine is. Okay, so in order to figure out the value of sine x, I need to first draw my diagram that represents the situation. So the first of all, you draw yourself a set of axes. And then you draw the terminal arm in the proper quadrant where x is. So what quadrant is angle x in? Third? 2. So I draw my terminal arm in quadrant 2. And then I want to produce a right angle triangle. How do I produce that right angle triangle? Okay. Right, always connected to the x-axis. So there's your right angle triangle. And then draw the angle x, place it in for your related angle spot. Now you just label the sides according to the ratio that they gave you. They told you that the cosine of x is equal to negative 3 over 5. So the cosine, by definition, is the adjacent side over the hypotenuse. And then I have to deal with the negative. What does the negative go in what? What? Exactly. Okay. So the negative goes with the 3, because remember, you're not labeling the lengths of the triangle. You're really labeling the direction. So you're going off in the negative x direction, so this is negative 3. The hypotenuse is never going to be a negative. It's always a terminal arm, so it's always a length. It's always going off. How do I figure out that side? David? Exactly. You do that. You figure out it's 4 is a positive or negative 4. Why is it positive? Right. It's going up in the x-axis over the positive y direction. Okay? So these diagrams, last time I did an example of drawing two of them because I gave you two different angles. I gave you X and Y. This one here, I'm just giving you angle X. This by far is the most important thing to draw properly. Okay, because now you're going to be reading off all your information from that diagram. So this is asking me what the sine of X is, and as long as I know what SOHCAHTOA is, then I can figure out that sine is the opposite side over the hypotenuse, and the opposite side is 4, and the hypotenuse is 5. So the sine of X is 4 over 5. So we can use this information now to figure out the sine of 2 times the angle. So I'm figuring out what the sine of 2 times the angle is without even knowing what the size of the angle is. Okay? Because I don't know what 2 times the angle is, but I know what the sine of the angle is, and I know what the cosine of the angle is. So what I would do is refer to my formula sheet, look at the double angle formula for sine, and say the sine of 2x is equal to 2 times the sine of x times the cosine of x. And because I know the sine of x and the cosine of x, I can substitute that in. And that allows me to figure out the exact value of the sine of 2 times the angle, even though I don't know what the angle is. Make sense? Okay. So let's figure out the cosine of 2x. Does everybody have the formula sheet on their desk? What's the difference between the sine of 2x and cosine of 2x? How many equations are there for the cosine? There's 3 of them. Okay. So for the sine of 2x, the sine of 2x is always equal to 2 times the sine of x times the cosine of x. But on your formula sheet, the cosine of 2x is equal to the cosine of x squared minus the sine of x squared. And then they give you 2 more. Okay, they give you 2 more because of that relationship that you learned back in grade 11, your very first identity, that the sine of x squared plus the cosine of x squared is equal to 1. And then I can figure out what sine x squared is or cos x squared by just rearranging this. So the cosine of x squared is equal to 1 minus the sine of x squared. For those of you on unit 14, right, these identities. And then the sine of x squared is equal to 1 minus the cos of x squared. So this identity is very important. You learned that back in grade 11. In grade 12, right, you're going to have all those identities that you have on that formula sheet when you do the next unit. Okay, so all they do now is they just substitute in and then rearrange. So they change the cosine of x squared into 1 minus the sine of x squared and then simplify. And when you simplify, you get this expression. So that's the second formula. Or you can change that the sine x squared is 1 minus the cos x squared, doing some math, and you get that. So there's this, or this. All 3 of them will always give you the correct answer. Sometimes it's easier to use one of them as opposed to the other. Okay? For example, if they want you to figure out the double angle formula for cosine, and they give you information about the sine, then I would use the one that has the sine in it. If they give you only information about the cosine, then I would use the one that has the cosine in it. If they give you information about the sine and the cosine, then you can use this one, or that. Okay? So just depending on what the question is asking. In this one, you can use any one of these 3 because we know what the sine is and we know what the cosine is. If I was doing it, I would use the one using the cosine because the original question gave me the information about the cosine, and then that way I don't have to rely on myself for getting the sine right. So the cosine of 2x is equal to 2 times the cosine of x squared minus 1. They gave me that the cosine of x is negative 3 over 5. Now it's just a matter of figuring this out. Negative 3 over 5 squared is 9 over 25. 18 over 25 when I multiply it. Find the common denominator and subtract off. I get negative 7 over 25. Okay, so I figured out from this information what the sine of x is, what the sine of 2x is, and what the cosine of 2x is. Okay. Question D, and I don't know the size of the angle at all, but we should be able to determine now what quadrant 2x is in. So what quadrant is 2x? Doesn't even make sense. What quadrant is 2x in? So going back, my original angle x, which I don't know the size of, but if I double that angle, it has two possibilities. It could end up in quadrant 3 or quadrant 4, right? And if you better with doing it in degrees, right? Like if I had 91 degrees, doubled it, it would end up in here. And if I had 179 degrees and double it, it would end up in here. How do I decide from the information that we have what quadrant my angle is in? I don't know the size of the angle. Sure?
Well, cos 2x is negative, and 2x is negative.
Awesome. What quadrant does that happen?
So it happens in quadrant 3.
Perfect. Okay. Because the sine of that angle worked out to be a negative ratio, and the cosine of that angle worked out to be a negative ratio. Because of the cast rule, down here in quadrant 3, both of them are negative. So the answer to that question is quadrant. Okay. Any questions so far? Over here. Next example. Next example given. Sine A is equal to negative 1/3. Determine the cosine for A. So in this example here, given that sine of A is equal to negative 1/3, determine the cosine of 4A. And again, determine the exact value, right? I should say. Determine the exact value of the cosine. So in this one here, there's no diagrams to draw because they didn't give us any information about angle A. We have no idea where it is. The only thing we do know is it's going to be in either quadrant 3 or quadrant 4, because that's the only place where sine is, has a negative ratio. Okay. How do you think we do this question? Yep. Nope. You could, but that would be extra work. You don't want to have to do that, right? Okay. So, do we have, Kevin, you have the formula sheet. Is there a cosine of 4 times an angle in your formula sheet? No. Okay, the only thing we have are the double angle formulas. So the double angle formulas for cosine, and there's 3 of them. It's the cosine of 2 times any angle. And I'm just going to write down a bracket here. Okay. So the cosine of 2 times any angle is equal to the cosine of that angle squared minus the sine of that angle squared, or 1 minus 2 times the sine of that angle squared, or 2 times the cosine of that angle squared minus 1. In this example, which double angle formula do you think I'm going to want to use? Remember, you choose on the information they give you, right?
Use the one that only has sine.
Right, because that's the only information we have, right? So that's the only one we can choose. So the cosine of 2 times any angle is equal to 1 minus 2 times the sine of that angle squared. And in our case, I want 4a. So what would I have to be putting in here? I would have to put 2a. Because 2a times 2a is 4a. So I got to figure out. Okay. So 1 minus 2 times the sine of 2a, and I'm just going to write it in a different way. It's easier for people to see. So this and this mean the exact same thing. Okay. Do I know the sine of 2a? Sorry, I should give us some information as well too. Cos A, I forgot to give us about cos. Cos A we'll say is that. I'm just making it. Okay, so do I know the sine of 2a? So what do? I don't know the sine of 2a. I have to get rid of that 2 somehow. I use the double angle formula. So it's 1 minus 2. And by definition, the sine of 2a is equal to 2 times the sine of a times the cosine of a. And now that I have it in terms of sine a and cos a, that information was given to me. So then I can substitute in the values that I know. Cos A was equal to, sine A was equal to negative 1/3. And cos A was equal to 2/3. And that whole thing is squared. And now it's just a matter of simplifying this. So this is 1 minus 2 bracket. And again, when you're multiplying fractions, right? 2 times negative 1/3 times 2/3 means you multiply the 2 by the top, not by the bottom. So you get negative 4 over 9 squared, which is 1 minus 2 over 16 over 81, which is 1 minus 32 over 81, which is 81 over 81 minus 32 over 81, which is something over 81, which would be what? 49? Yeah, 49. 49. So in this question here, we're given what sine A was, and then I'd originally forgotten to give you the value of cos A, but if we give you the value of cos A here, and then cosine of 4a, we didn't know what it was, so we had to use the double angle formula, and then we had to use the double angle formula again, so that you get it in terms of just your angles just in terms of a, and then you have that information you substitute in. Okay. The next part is just going to be coming from your guide. If you have your guide, you can open it up so you know what I'm referring to. On page B5 of your guide, if you cover up the solution, the example 4 is exactly like what you're going to get on the second page of your test. Okay? So it gives you information about angle A, and it gives you some information about angle B. Draw the diagrams. The diagrams are done for you there, but cover them up and try to draw them by yourself, because that's the most important step. And once you've drawn them by yourself, they do an example of the cosine of A minus B. But I'd like you to try to figure out these examples, because it'll help you to study for your test. Because they only do that one example. But it's probably a good idea to practice it with these types of questions as well. Okay, so on the top of B5, use example number 4. Read the example, cover up the solution, don't look at it. Okay, try to draw the diagrams because that's the most important part. Once you get the diagrams, answer these questions right here. If you can do that, you can do the second page of your test. Any questions? Okay, so that's all we're going to do today. Tomorrow, we're going to do another lesson on trigonometric equations because I'm not here on Wednesday, and Wednesday will be a test day. Okay, so if you want to write a test, you can write it on Wednesday in class. Thursday, we're going to finish up the guide, and Friday will be a lesson day. If anybody has any concerns, you really want to write your test tomorrow, I can find another period. I don't want you to miss the lesson, but I can find another period for you in which you want to write it. Okay? So if you have any concerns, talk to me. If not, Wednesday is a test day, and Friday will be a test day. Every other days are lesson days. So as